Well, as we start our lecture on tropical cyclones, I want to show you Isabel. Isabel from 2003, one of the most powerful hurricanes of that season. Very symmetric, very just beautiful to look at from outer space. But underneath this cloud shield, which you see here, is one of the most powerful expressions of weather on Earth, a hurricane. And this particular one reached Category 5 strength and intensity. And we're going to be learning throughout these lectures how hurricanes form. Why do they take this shape? Why do they have eyes? Why are they so powerful? Why is it so important to understand their track? And why is it that they can cause so much damage? But in terms of hurricanes, it doesn't get much better looking than Isabel. In fact, here's an amazing image of Isabel, the eye of Isabel from the International Space Station. So you're looking into kind of this deep kind of cavern of clouds here into the center of a powerful Category 5 strength hurricane. This kind of layering of clouds here, well, that may be 6, 7, 8 miles tall. It's absolutely incredible to see this. Now, when it comes to the naming of hurricanes, not the names that we use every single year, but why they're called hurricanes, there's a very interesting history of that. And I think before we get any farther into how these tropical cyclones form and what they do, we should take a quick kind of tour through history. And I want to start in Cuba. You see, in Cuba, there was an ancient people that lived there. They were part of the Mayan civilization called the Taínos people. And they had a very interesting kind of mythology about the creation of Earth. And here's how it goes very quickly. They had a goddess named Atabe, and Atabe was responsible for creating, Earth and all of the heavenly bodies. Basically, she was the reason there was existence. She bore 2 sons. And when she had those 2 sons, she assigned them the task of creating Earth and creating all the amazing things on Earth. The first son, when he was born, made everything that was beautiful. So everything that you think is beautiful, the mountains, the valleys, the trees, the oceans, everything, all of the beautiful stuff on Earth. When the second brother was born to come along to help the older brother, he became incredibly jealous. And in that jealousy, decided to destroy all of the beautiful things that his older brother had created. And he did it with a terrible wind. Now, this is according to this Mayan, mythology here. In the process of destroying Earth with this incredible wind, he renamed himself. And the name that he was given, Huracan. Huracan, what a cool name. Now, over the centuries, that word has been anglicized and is now the word hurricane. But it's just amazing to just step back and think about that. That's how we got that particular word. Now, let's fast forward a little bit. I want to take you to about 1260 over in East Asia. At this time, the grandson of Genghis Khan, Kublai Khan, was trying to take over basically the world. From Mongolia, taking over parts of China, certainly took over the Korean peninsula. And the next thing that he wanted to do was take over Japan. So Kublai Khan basically commissioned the building, or forced the building, of 900 ships by the Koreans, onto which he was going to pile 40,000 sailors and soldiers, and then sail over to Japan and take the island by force. Well, interesting turn and kind of events in history here. The expedition to basically destroy Japan happened in the summer, and while they were going toward Japan, and when they got there and met those northern islands first, there was a small resistance, but it didn't delay them much. But the problem was they went in late summer. And the Koreans who built the ships for the Mongolians were looking off to the east, and they saw the skies darkening, and they said, listen, here comes one of these powerful, powerful storm systems. Let's get back in the boats, get away from the shore. And this is kind of a picture of what some of those boats may have looked like. Get away from the shore and ride this thing out at sea. So you don't ever want to be on the shoreline with a boat that's kind of at dock or moored to the shoreline when these massive crashing waves come through. They'll destroy everything. Well, Khan, along with the rest of the Mongolian soldiers, basically ignored the warning, and they stayed. And then at the last moment, when this powerful tropical cyclone was bearing down on Japan, they decided to run to their boats and try to get back into open ocean, but it was too late. And most, if not, nearly all of the boats were capsized and destroyed, and basically only Khan survived. We're back to China. Okay, so basically the first time that they attempted to take over Japan, the Mongolians did, their efforts were thwarted by a powerful, powerful tropical cyclone. So Khan goes back, he's now upset, takes over parts of China, makes the Chinese and the Koreans build more boats. He's going to go back with 100,000 soldiers and sailors. Wants to leave earlier so that they can avoid tropical cyclones. There's production delays. They leave 6 weeks later. try to take over Japan, and guess what? Another powerful tropical cyclone knocks out the Mongolian army. And twice in history, Mongolia was prevented from taking over Japan because of tropical cyclones. So the Japanese named these tropical cyclones kamikaze. Now, we probably have a little bit different affiliation with that word. Maybe some of you are thinking about World War II in Hawaii, or maybe you're thinking about a drink you've had recently called the kamikaze. But the word kamikaze, which comes to us from the Japanese, translated means divine wind. So both of these powerful tropical cyclones, or kamikaze, basically saved Japan from being a part of the Mongolian Empire. Now let's fast forward way, way, way farther, and let's get to 1942. Here's an interesting bit of a story. Out of Texas, there were two men, Duckworth and O'Hare, and they were pilots. And on a $1 bet with some other people out of Houston, Texas, they bet that they could fly through the middle of a hurricane, take pictures from the inside, and fly back. So they did it on a $1 bet and survived the event. And what's amazing is, it really turns out that flying through the eye of a hurricane, flying through the eye wall of a hurricane, is not nearly as impossible of a task as it is to fly through a massive severe thunderstorm. Because hurricanes have incredibly powerful winds that come from that are horizontal, come from sideways. Whereas supercell thunderstorms and squall lines and big nasty thunderstorm complexes, they have strong vertical winds. And it's much easier to fly through those strong horizontal winds than it is the vertical winds. And that began the modern era of reconnaissance, flying into hurricanes to capture some of the most amazing and stunning images and the best data we could possibly ask for so that we can predict hurricanes. So you see, when we're talking about all this stuff, it has a long and rich history about how this all works. Now, if we go back to this original symbol, this is pretty neat. This is the symbol that the Cubans, basically those Taínos people, those Mayans that lived on Cuba, this is the symbol that they tied to the evil god Huracan. And it was amazing because it was kind of like this face with these two snake-like arms, and they would actually go out and perform rituals out on the edge, the eastern edge of the island, to kind of ward off the evil god Huracan every year. What I love about it is the symbol that they used is very similar to the symbol we now use to denote hurricanes and tropical storms on maps. And by the way, one last thing about hurricanes. Recently, in the last couple of years, Lamborghini decided to release a car called the Huracan. They made a promotional video in which they really kind of screwed up. They tried to make it look as though in the promotional video the guy was going to drive this Lamborghini Huracan and outrun a hurricane. But what they actually showed was a supercell thunderstorm. They didn't look anything alike, but whatever. And just as a side note, Lamborghini names its cars not after weather systems. They're all named after famous Spanish fighting bulls. So I don't get it. I don't know why they made that the promotional video. I wish they would have contacted me first, because it would have really helped them figure this out, because they used all the wrong imagery from hurricanes. So speaking of imagery, check this out. That's Katrina. Katrina, up to this point, this is June 2018, Hurricane Katrina is the most costly U.S. natural disaster ever. And from above, we see some spectacular imagery here from our low Earth orbiting satellites. This is a MODIS image. But I want to tell you something about this. If you were to be under this hurricane, it's not photogenic. It's not got really crisp, defined cloud edges like we see in supercells and squall lines, where there are shelf clouds and wall clouds and all sorts of amazing things like mammatus and other neat clouds you're going to learn about this semester. Instead, it is just wet, extremely windy, and gray. So they're only beautiful from outer space. But this is what one looks like. And they're huge. And they contain an enormous amount of energy. Now, just to make this clear, on the left, I have some statistics about tropical cyclones. And on the right, I have a picture here of the Moore 2013 EF5 ranked tornadoes. So hurricanes on the left, tornadoes on the right. Just so that you understand, yes, both are violently spinning, columns of air. But make sure we get the differences. On average, there's between 10 and 15 hurricanes a year in the Atlantic Ocean. In the United States, 1,200 to 1,500 tornadoes. So there's a difference in number. Secondly, hurricanes cost billions because they're huge. And when they make landfall, they destroy a lot of stuff. Tornadoes, millions. Still, when they hit stuff, they can cause a lot of damage. Hurricanes can last over a week. Tornadoes, maybe 30 minutes or more. How long does it take for a hurricane to develop? Several days. We can have tornadoes develop in seconds. We are much, much better at warning hurricanes and predicting them. It's nearly impossible to warn on a tornado more than just 30, 40 minutes in advance. Hurricanes are massive, up to 1,000 miles wide. Some are even bigger. Average width of a tornado, 250 yards wide, which means you could fit a whole bunch of tornadoes inside the eye of a hurricane. How fast are the winds? Well, they're both ridiculous. Max wind speeds in a hurricane, maybe 200 plus miles an hour. Tornadoes, over 300. How do hurricanes kill you? They drown you, or they have structures that collapse around you. Tornadoes do it with debris. They throw stuff. When do we have hurricanes? Basically June and November, peaking in September. And when it comes to tornadoes, it's March to September, but May would be the most active month. So these are the differences. I just want to point them out because if you do a quick Google image search of the word hurricane or tornado, you'll often get images of both. And it's kind of a confusing thing. So we'll toss that in there to get started. Okay, let's get into some of the details here. This is a pretty cool map. In the background here, you have a bunch of squiggly lines, and each line represents a tropical cyclone track. So we can kind of see where they form around our planet. Let's talk about it. First, on average, there's about 80 of these things per year. About 50, maybe up to 70% of them achieve hurricane strength. Now, what is that? To be considered hurricane strength, the minimum sustained wind speed needs to exceed 74 miles per hour. Okay, so that's what it is. So that means the minimum sustained wind speed is 74 miles an hour or faster. Next, we call them hurricanes here. We call them typhoons here. This is where they were once called kamikaze, now they're called typhoons. And they're just called cyclones here. So again, look at this. Hurricanes in the eastern Atlantic and in the western Atlantic and in the eastern Pacific. Typhoons in the western Pacific. And then cyclones in the Indian Ocean and in the southern Pacific and southern Indian Ocean. Next, I'm going to black out the southern hemisphere. Number I want you to know. 2/3, about 66% of all tropical cyclones are in the northern hemisphere. If we kind of take that away, you'll see that there are some parts of the globe where we have a lot of ocean water, but it's too cold here and here for hurricanes to form, either too cold or too high a wind shear. Now, we have had a couple of them that have formed down here in the South Atlantic. I'll show you this one in just a few minutes. But it's very, very rare in these two ocean basins to have hurricanes or tropical cyclones. Next, where do they typically form? Well, we're going to be learning about something very, very cool in this video series on tropical cyclones. It's called the Coriolis effect. So we'll get to it very soon. But basically, the Coriolis effect is negligible, practically zero. It is zero on the equator. And as a consequence, hurricanes, because they use the rotation of the Earth to spin themselves, cannot cross the equator. Once you get farther than this line on top here, the waters are just too cold. So what are these lines? Well, these two top lines, this one here and this one down here, are at about 30 to 35 degrees north or south. And these two lines are 5 degrees north and 5 degrees south of the equator. So that's kind of your range, about 5 degrees to 35 degrees north and about 5 degrees to 35 degrees south. That's where we find hurricanes, where the waters are warm enough and everything's kind of coming together to make them happen. So if we pull that away, again, look, no tropical cyclone that we have on record has ever crossed the equator and gone to the other hemisphere. But let's talk about this one right here. This is an image of that particular hurricane. Very, very rare. So this is the coast of Brazil. And this particular hurricane had no name. And when it made landfall here. And when it made landfall, it hit this region called Catalina. So they named it Catalina once it was done. Now, something neat to see here, we're in the southern hemisphere, so this hurricane is actually spinning in this direction, and we're going to talk about that why in this video lecture series on tropical cyclones. Why do they spin in certain directions in different hemispheres? Okay, here's a quick question for you, all right? I've got 5 regions labeled. Which region has historically recorded the most fatalities, the most deaths from tropical cyclones? Is it the Indian Ocean, the Western Pacific Ocean, the South Pacific Ocean or the Southern Indian Ocean, that would be C, the Eastern Pacific Ocean over there by Mexico, or the Western Atlantic? Take a moment and think about it. Now, when you look at this, you might be saying, wow, it's got to be here in B. I mean, just look at all of the cyclone tracks. I mean, this is the most active basin there is on Earth, the Western Pacific. But check this out. This is a list of the 35 deadliest tropical cyclones in world history. Are you ready? Bangladesh, Bangladesh, Vietnam. India, Bangladesh, Bangladesh, Bangladesh. China, Bangladesh, Myanmar, China, India, Japan. Bangladesh, India, India, Bangladesh, Bangladesh, India, India. Right here. And the reason why? Population. There are, in this little circle that I'm drawing here, 1.5 billion people. And those people live in a region that when hurricanes make landfall, the flooding is catastrophic. Over here in Japan and in China, yes, big populations, but they've evolved such that they're very used to this. The infrastructure has evolved. The people are used to these kind of massive events. And the way that everything is set up there, we have fewer fatalities than we do whenever we have a big landfalling tropical cyclone in the Indian Ocean. So it's A. There's that list again. Incredible to see some of those numbers. The deadliest, the Great Bola Cyclone of 1970, possibly up to 500,000 people killed in Bangladesh. All right, hurricane tracks. This will be the central theme through this entire lecture series, so pay close attention to this. Hurricane tracks look something like this. In the Atlantic, and actually this looks what it looks like all across the northern hemisphere, hurricanes move from the east to the west and curve to the north. Now, hurricanes are steered by winds called the trade winds. We're going to learn about them in just a few minutes. Those are winds that basically blow from the east to the west. They're an easterly wind. But the reason why they turn to the north is there's a couple reasons, but the big one here is they're kind of turned to the north by this, again, this new term, the Coriolis force or the Coriolis effect. They also kind of turn north in the Atlantic because generally there's a large area of higher atmospheric pressure that sits right here in the central North Atlantic. And the winds from this kind of steer the hurricanes right around the outside. Now I put on here a bunch of pictures of different hurricanes with the dividing line. Check it out. What I've got over here, I've got Bertha. This is Bertha's track. Bertha basically started like this. Very typical track. You can see kind of the typical nature of it going just like this. We've got Dean. Dean was very typical, but Dean just made landfall before it ever got a chance to turn back to the north. Wilma started in the Caribbean. Look at this, very typical path. Camille, Caribbean, hit near New Orleans, very typical. And even Umberto, that's not Humberto. Umberto started in the Gulf and was doing that typical track. So that's it. You see these arrows down here, or these tracks down here look just like these arrows up here. Now, when the trade winds become weak, the hurricane basically just follows around the warmest water. Look at Kyle in 2002. I'll never forget it. This was my first ever semester teaching. Kyle meandered quite a bit. Started here, did one loop-de-loop, did a second loop-de-loop, did a third loop-de-loop, then got its act together, headed toward Florida. We warned the Florida coastline, and instead it turned north, hit North and South Carolina. So this is just what happens when a hurricane is just basically out of steering winds and just follows warm water. Ivan, very normal. Look at this. East to west, turns north, slams into parts of Alabama, Louisiana, Mississippi, and Florida. Tries to exit the East Coast United States. And then why it turned back south? Well, the steering winds pulled it back around, hit Florida, couldn't get enough of the United States, so then went over and hit Texas. 3 times, 1 hurricane. That's crazy. So all of this is normal. This is what's weird. And Gordon started off very normal. This is a normal track. Gordon was buzzing straight toward, as a kind of a weakening system toward the Portugal coast right here. Instead, turned north, hit Ireland, came back around, hit Ireland again. This is the weird part of that particular circulation. So you can see, what it looks like to see a typical track and an atypical track. So very interesting to see that. Tracks will be the central theme throughout these lectures. What about the Atlantic hurricane season? So let's focus in on the Atlantic here. We define it as June 1st to December 1st. And where we get that information is basically from this histogram. This is showing us the average number, not the average number, the total number per day of tropical systems for the last 100 years. So we can see it typically begins right around June 1st. We get our most active time period, peaks September 10th, and then wanes after that. And the reason why we have this peak right here is because ocean temperatures, sea surface temperatures govern hurricane strength. And because water takes 5 times as long as land to heat up, well, we get our peak heating from the sun at the beginning of July. But it takes a couple of months after that for the oceans to really warm up. And that's why when you look over here at these images, even though June and July are very hot months, it takes a little bit of time for the oceans to get hot. So we start to see the hurricane season really ramping up like you see here in August, September, and then begins to wane in October, November. So these maps from the National Hurricane Center just show us where we typically find hurricane development throughout each month of the year, September being the broadest extent. Now, there's a really cool map put out here by the National Hurricane Center. And what it shows you is the return period. In other words, how often hurricanes come back to a particular area. When you look at it, there's really just a few points that are hit quite often. It's this region here in Louisiana, Mississippi, it's the southern tip of Florida, and it's this Cape Hatteras region that all have return time periods between 5 and 7 years. And we're going to talk about why those areas have such higher return time period than the Northeast coast, than this little cove in here, or this one right in through here, or even along the Texas coast. So we're going to talk about those areas in just a few minutes. But this basically defines for us what the hurricane season looks like. Now, speaking of hurricane seasons, here's a fun question. What is the record for the most named, remember we give them names, most named tropical cyclones in the Atlantic in one hurricane season? I think it's 15, 18, 22, 28, or 36. That's just a guess. What do you think? Well, the image you're looking at there, that is Hurricane Wilma. So we know we made it we made it all the way to the letter W during one of our seasons. Well, let me tell you about these seasons. You see, in 2004, we had 15 named storms. Now, that's actually not too far out of the ordinary, but 9 of them became hurricanes, 6 of them became major hurricanes, and that is above average. The problem? 4 of them, Charlie, Francis, Ivan, and Jeannie, or Jeanne, hit Florida. In fact, 3 of them hit the same spot in Florida. And as a result, $58 billion in damages. 3,200 fatalities from this season as well. But most of those fatalities are when Jeannie, or Jeanne, hit Haiti. Haiti's one of the most vulnerable places on Earth in terms of hurricanes making landfall. But here's the record, 28. In the 2005 hurricane season, which followed 2004, 28 named storms, 15 hurricanes, 7 were major. You know what normal is? 6 hurricanes, 2 major. We ran out of names. The contingency plan used the Greek alphabet. We had 5 Category 4s and 4 Category 5 strength hurricanes. Normally, we have a Category 5 strength hurricane every other year. That's its normal kind of time period. Wilma set the all-time record for the lowest pressure in the Atlantic Basin. 5 hurricane names are retired. Katrina is now the most costly U.S. hurricane ever. Total damages, $200 billion, which was, at the time, the most expensive. We had 2,280 deaths, and over 1,800 of those were from Katrina. And so this was an incredibly, incredibly active season. All right. So some questions about Katrina, since Katrina is currently the most costly hurricane ever to hit the United States. How many times did Hurricane Katrina hit the U.S.? Was it once, twice, 3 times, 5 times? What do you think? Well, the answer to this one? Twice. A lot of people forgot Katrina hit Florida first before it hit New Orleans. Another question. How strong was Katrina when it made landfall in New Orleans? Cat 1, 2, 3, 4, or 5? Well, Katrina, when it was out in the middle of the open Atlantic, was a Cat 5. When it was in the middle of the open Gulf of Mexico, was a Category 5 strength hurricane. But by the time it hit New Orleans, it was downgraded to Category 3. But it still had Category 5 strength storm surge. We'll talk about that soon. Finally, this is just kind of a quick geography lesson. I'll never forget this day. My sister called me from Indianapolis, Indiana, and she says, "Eric, what is going on? We have this massive hurricane. Do I need to be prepared?" Well, my little sister, she's brilliant. She's a math teacher, and she's just absolutely brilliant. But she is geographically challenged. She lived here, and she thought that she was in danger from this hurricane. She says, "Eric, where's New Orleans?" And so in honor of my little sister, here's the question. Which letter's over New Orleans? All right. If you've looked at the map, let me tell you something. E, Cape Hatteras. D, Miami. C, Tampa. A, Houston. B, New Orleans. And Katrina came in just like this. Now, interestingly enough, Katrina took off a track just like that. And my sister here in Indiana did get some clouds and some light rain showers from the remnants of Katrina. Still wanted to show you that particular or share with you that funny story about my little sister. Let me show you Katrina in animation here. This is from NASA. Check this out. This is absolutely breathtaking. Here is Katrina in the middle of the Gulf of Mexico at Cat 5 strength. But let me take you back to the beginnings of Katrina. So as we animate here, let's go over toward the Bahamas, where Katrina was born. You see, Katrina was born out of a group of tropical thunderstorms. These are just normal thunderstorms over the middle of the ocean here. But they quickly organized and became tropical depression, and that tropical depression organized into a tropical storm right about now. And that's where it got its name, Tropical Storm Katrina. Katrina did something that I'd never seen another hurricane do, and that is go over land as a tropical storm, but then strengthen right here. Let me pause this, okay? Strengthen as it went across Florida to become a Category 1 strength storm. Normally, when hurricanes hit land, they're weakened. They lose their moisture source, they lose the heat, and the land adds friction. But sometimes when hurricanes cross the southern tip of Florida, they can maintain strength or even strengthen. Because the southern tip of Florida is basically still ocean. Remember, the Everglades are down there. That's a lot of water. And Katrina used the heat and the water to stay strong. Now, it's in the open Gulf of Mexico, and the sea surface temperatures are warm and the wind shear is low. We have Category 1 strength Hurricane Katrina right here. Ready? Now it's a Category 2. It's strengthening up to Category 3. Big eye pops out right about there. It's now Category 4. Category 5. The northern edge hits land, weakening the northern side of the storm, and it makes landfall there on August 29th as a Category 3 strength storm, hitting the major metropolitan area of New Orleans. Incredible to see video like this. It's pretty neat, by the way. Google tracks hurricanes. So next time there's one that's happening, go check it out. Gives you all the data from this particular system, for each system, I should say, that goes across the world. Pretty amazing to see that. I want to show you what Katrina looks like here. Upper left-hand image, that is a MODIS satellite image of Katrina. Bottom left, that is a radar image, the last radar image we could get from Katrina because the northern eye wall of Katrina destroyed the radar. And this is the hurricane hunter's view of Katrina. And just to make one point, this is the ocean floor, and this is the top of Katrina's clouds. That is the troposphere. Up here, we're in the stratosphere, and this is the clear eye. So you're looking at a wall of clouds that may be, I don't know, 8, 10 miles tall. Incredible, incredible to see that. This is the hurricane hunter's view as it flew into the eye of Hurricane Katrina. Now, what made New Orleans so vulnerable? Well, if you don't know much about the geography of New Orleans, there's a substantial part of it that is below sea level. So this is a cross-section. On this side, we have the Mississippi River, and here's one of the flood walls that protects the Mississippi River from getting into New Orleans. Over here, Lake Pontchartrain, another flood wall. There's a system of canals between the Mississippi River and Lake Pontchartrain that basically help control water. But look, much of New Orleans is below sea level. And when those levees failed because of Katrina's incredible rainfall and storm surge, well, this is what happened to the city. Got these great images from NASA here, before and after. The before are on the left, the after on the right. We basically turned New Orleans into Venice. Just filled the streets with water. When it was all said and done, some 50,000 homes are still, this is 2018, are still abandoned in New Orleans. And as a consequence of all this flooding, we're looking at a disaster here that is, well over $150 billion in damage. And those damages are hard to estimate, and they're going to continue to get bigger and bigger with time as we see the long-lasting effects of this powerful, powerful hurricane. So that's just your short and sweet kind of description of what happened and what it looked like. But Katrina, currently the most costly U.S. natural disaster ever. All right. Sandy was another powerful hurricane. This one hit in 2012. But before we talk about it, I'm going to show you a little bit different map. Remember we looked at a map a moment ago that showed the return period for hurricanes? Well, this one kind of shows a similar thing. We're looking at strikes between 1900 and 2010. And when you look at it, look at the color coding. The cooler colors here represent the less frequent landfalling systems, and the warmer colors are more frequent. So when we see this, I want to put over the typical hurricane tracks. You see, the reason why Florida and Louisiana and North Carolina get hit so often is that they stick out into the ocean. Whereas we have these regions like right in through here that are kind of protected bays. It's hard for a hurricane to come in and go right into this part of Georgia because normally what will happen is it'll get on the Gulf Stream or catch the westerly winds and get pushed away and hit New Orleans. So when you look at this, we see that there are a lot of regions that are hit very frequently and some regions that are not. Now, when you come up here farther to the northeast, this region is rarely hit because typically the waters are too cool and because of the shape of the coastline. Again, see how it's kind of a broad sweeping bay except for, Cape Cod out here. So it's quite rare for them to get that far north, but they can do it, okay? Now I'm going to show you something neat here. What I'm showing you is I'm taking you back to October 23rd and October 25th of 2012, and I pulled out the ensemble forecast data. Now, what is that? Well, every time we go to simulate the path of a hurricane, we don't just do it once. We actually simulate it multiple times, where each time we do it, we kind of perturb or we change the initial conditions of the environment around the hurricane and then simulate its forward path. So each one of these squiggly lines you see here, the white lines, is a different simulation. Now, if they all clump together, well, then we know that there's a lot of model agreement. But when they start to diverge, well, that makes things quite interesting. Well, I'll never forget October 23rd because as Sandy was kind of showing up right here in the Caribbean, some of the ensemble forecast members took Sandy and basically hard left turned right here into the northeast, into a region that's very rarely hit. And we were looking at this on the 23rd. It was several days out in the forecast. And we're saying, gosh, if that happens, that's hitting a major metropolitan area. This is, kind of the biggest metropolitan area of the United States. And why was it happening? Well, here across the United States, there was a forecast for a big trough in the jet stream. And that trough has winds that kind of circulate counterclockwise. It was going to grab Sandy and turn Sandy right here into the northeast. 2 days later, all of the ensemble members were in agreement with that hard left turn. And people here started to get quite worried. Now, Sandy was going to weaken, and Sandy most certainly did weaken as it moved toward the north over those cooler waters. But still, it was a powerful, powerful hurricane that covered a lot of ground and caused an enormous amount of damage. Now, let me show you how rare Sandy's track was. Here you're looking at major hurricane tracks throughout history. And you can clearly see they basically start off the coast of Africa and they follow the tracks we talked about, right? East to west, turn to the north. This was Sandy. Look at that. And as a consequence, Sandy is now the third most costly U.S. natural disaster ever. Third most costly, because it made a hard left turn right there into New Jersey, near New York, near Washington, D.C., the most densely populated place in the U.S. And when it did this, it just caused so much trouble. So we're just kind of taking a look here at some major hurricanes. Now here's an interesting question for you. How many Category 5 strength hurricanes have made landfall at Category 5 strength, that's the highest level, in the United States in the last 100 years? What do you think? I'm showing you a picture there of Katrina. Was it 1, 3, 9, 24, or more than 24? Well, you might be interested to find out that the answer is just 3. Just 3. One of them I don't have a picture for. It was the Labor Day hurricane of 1935. To this day, it was the most intense landfalling tropical system to ever hit the United States. It hit near the Florida Keys. But the two most recent, 1992, Hurricane Andrew, and 1969, Hurricane Camille. Camille, we're going to talk about a whole lot more when we talk about storm path and comparing it to Katrina. But when it made landfall there, very close to New Orleans, it was devastating. And its wind speeds, 190 miles an hour, which were record-setting at the time. Over on the left, though, I have Andrew. And Andrew was a major, major success in terms of evacuation in U.S. history. Even though Andrew did so much damage with 165-mile-an-hour winds crossing the southern tip of Florida in just 4 hours, destroying 95% of all structures in Dade County and Broward County, mobile homes in Dade County and Broward County, and causing so much damage in other locations as well. You can just see the pictures here. Why Andrew was a success is we employed something called contraflow. Contraflow is where you let all major roadways be outbound roadways away from a coastline to get people away from the storm surge and away from the fastest winds. We employed that technique and got people out of the way, and as a result, even though it was a major, major landfalling hurricane, we had very few fatalities. But I want you to listen up to something very important here. We're going to talk about mandatory evacuations while you're looking at these pictures. You see, if there's a mandatory evacuation of a hurricane in your location, evacuate, leave. Don't hang around, don't wait, get your valuables, get them in the car, and get out of there. And the reason why I say this is because of a couple of reasons. In some municipalities, some counties, some states, you can be fined for not obeying the mandatory evacuation. And also, when a mandatory evacuation is sent, that mandatory evacuation is for everyone, including police, firefighters, rescue workers, they're not going to stay around either. So if you decide to stay, remember those people are gone, which means they're not going to be there to save you. Here's another thing. It has been, there's precedent for this. It's been found that, imagine that I decided when maybe like a massive hurricane, like Hurricane Ike was going to hit Houston. Imagine I lived in Houston or Galveston, and I have two kids and my wife. I decided, you know what, let's just stay here and ride this one out, even though there's a mandatory evacuation. Now listen up. If during that hurricane, I was forced to abandon my house, and we just had to ditch the house and get into the floodwaters and try to swim to safety, if when that happened, my 2 children drowned, my wife and I would be liable for manslaughter, prosecuted in a court of law. Manslaughter. Don't mess around with this. If you're told to evacuate, evacuate immediately. Okay, let's talk about hurricane fatalities. The graph you see here starts in 1940 and goes to 2017. When you look at this graph, the y-axis is the number of fatalities. Now, on average, over the last 30 years, that's 1986 to 2017, 47 fatalities per year. But when you look at this graph, I want to point out something very interesting. Yes, Hurricane Katrina is a major anomaly. But since 1975, right here, do you notice that after this, it is very rare to have a hurricane season where we have more than 50 fatalities? Before 1975, we had many hurricane seasons, even with weak hurricanes like Connie, Diane, Carol, and Hazel, Agnes, where we had well over 100 fatalities, sometimes over 300 fatalities. What happened in 1975? Do you remember? It's not that we've had fewer hurricanes. Look, we've got Gilbert, Hugo, Andrew, Charlie, Francis, Ivan, Jeanne, Katrina, Harvey, Irma, Maria. We've gotten slammed by hurricanes. The difference? Satellites. The geostationary satellites launched in 1975 revolutionized hurricane forecasting. So that's that. I want you to also remember this. The numbers you see here are tiny, absolutely tiny compared to other locations. Cyclone Nargis hit Myanmar, also called Burma, back in 2008. It killed 140,000 people. 140,000 people just a few years ago. So when you think about the United States, it's our infrastructure, our warning system, the National Hurricane Center that keeps us safe. If you live in the U.S., be thankful that such agencies exist. They do a phenomenal job. Talk about 2017. 2017, we don't know what the total cost is going to be just yet. It's too early in 2018 to know it. But some estimates put 2017 somewhere around $350 billion in damage, maybe even bigger. Most of it, Harvey, Irma, and Maria. See the hurricane icons down there at the bottom? 3 huge hurricanes hitting major metropolitan areas. Yeah, we had flooding, we had tornadoes, we had wildfires, we had drought. We even had a nasty freeze event down in the southeast. But all of those just pale in comparison to the total damage costs by Harvey, Irma, and Maria of 2017. So let's talk about all of this. When it comes to the most expensive weather disasters, I have a list here. I made this list before the 2017 hurricane season, so I had to make a couple of adjustments here. Before the 2017 hurricane season, Katrina, Sandy, Andrew, those were the top 3. Now it goes Katrina, Harvey, Maria, Sandy, Irma, Andrew. Incredible to see the differences here just because of how powerful that season was. Harvey at 125 billion. By the way, when you look at this, look down the list. There is only one event on my list, the super outbreak of 2011, that is not from either flooding or drought. In the super outbreak, that was a tornado outbreak. We'll talk about that when we get to the tornado lectures. Everything else is either flooding from a hurricane or massive drought. It's all about water. All right, here's a neat graph. This was put out several years ago. It was from a paper that tried to normalize hurricane damage cost. You see, outright Katrina ranks number 1, okay, at somewhere north of $150 billion when everything is kind of put into 2005 dollars. But when they normalize things, turns out that the Great Miami Hurricane in 1926 is the most costly. Now, again, it wasn't even close to what Katrina cost in 2005 dollars. But when you put it out, account for inflation, things like that, the Great Miami Hurricane, that's the most expensive. Neat to see that. Okay, tune me in here. We're going to talk about stages of development. Got this incredible graphic that shows how a group of tropical thunderstorms coming off of Africa can form into a massive hurricane. What I want you to pay attention as you watch this video is the stages of progression and what defines them. So let's start off with what we got over here on the far right. You see, off of Africa all the time, we have these thunderstorms that roll off. They form on what we call easterly waves. And these easterly waves create these clusters of tropical thunderstorms. When these clusters of tropical thunderstorms form, the National Hurricane Center begins to investigate them, watches them. In fact, we call them Invest 94, Invest 99. We just give it a number and we put the word invest in front of it to let the public know we're watching it. You see, what we're going to discuss when we go through the stages of development here is that tropical systems go through a very, very kind of prescribed sequence of events. And that sequence of events is all kind of gathered around this organizational process. So a tropical disturbance is the first of this sequence. When we get those thunderstorms to organize themselves, and what I mean by that, they organize themselves around a very weak low pressure system right here. See the little L? They begin to orbit that low pressure system. Now, why does it get low there? Why is there lower pressure? Well, the heat from the storms lowers the atmospheric pressure, lowers the density, and the atmosphere tries to fill that back in. And as that happens, the winds circulate around that low. If those winds that are circulating those thunderstorms around the low maintain a speed between 22 and 38 miles an hour, we call it a tropical depression. And the word depression is referring to the lower surface pressure. It's a depression in the surface pressure field. Now, as that low develops, and we classify it as a depression, and the sustained wind speeds are over 22 miles an hour, we give it a number. And it just goes in numeric order. So there's tropical depression 1, 2, 3, 4. And if I remember right, Hurricane Katrina was tropical depression 12 of that year. Now, as the organizational process continues, we move up to tropical storm strength. To get there, we have to have the storms really get powerful and large and release a lot of heat such that the pressure drops off even farther, deeper. When we have this intense cluster of thunderstorms that are circulating around the low right here, maintaining wind speeds of 39 to 73 miles an hour, it's called a tropical storm, and that's where it gets a name. So Tropical Depression 12 became Tropical Storm Katrina. As this process continues to evolve, as the low pressure center gets lower and lower and lower, the winds get faster and faster. That's simple. It's a pressure gradient thing. We learned about this. Deeper and deeper pressure gives you a bigger and bigger pressure gradient, faster the winds. Once the sustained winds exceed 74 miles an hour, we have a hurricane. And the name that it was given as a tropical storm is kept once it becomes a hurricane. When that happens, wind speeds are over 74 miles an hour. The winds are incredible. The rain, torrential. The storm surge, deep, maybe up to 30 plus feet. When a hurricane forms, life and property is in the way, it is going to be catastrophic. So disturbance is called we're going to investigate it. Depression, we give it a number. Storm, we give it a name. When it becomes a hurricane, it keeps its name, and we start to classify hurricanes using the Saffir-Simpson scale. So these are the stages of development: disturbance, depression, storm, hurricane. All right, where do we get the word Saffir-Simpson scale? Well, I got a picture up there of Herbert Saffir. Herbert Saffir was a structural engineer. His colleague, Bob Simpson, was the director of the National Hurricane Center. Basically, the pair, one knew how wind could destroy things, the other one knew why there was wind. And they made this very simple scale. They ranked the hurricane based on sustained wind speed. And what we use here in the Western Atlantic is a 1-minute sustained wind average. Other parts of the world can use up to a 10-minute average. We use a 1-minute average. So what I like to remember in this chart, you get above 74, you're Cat 1. Above 155, you are Category 5. Now, how long do these things typically last? Well, once they become a hurricane, as long as they're not too close to land, maybe 2 days up to a week, they can maintain hurricane status. Ginger, 27 days spent as either a tropical storm or a hurricane. This was back in 1971. That is the longest lived one that we know about. How big are they? Typical diameter, let's call it around 500 miles wide. So I got this image up here, 500 miles from outside of the cloud shield from one side to the other. The eye, maybe 10 to sometimes 50 miles wide. And what was the biggest one ever? Well, the biggest one we've ever witnessed, 1979, Super Typhoon Tip, Category 5 strength typhoon, 1,350 miles across. Smallest, Cyclone Tracy, Cat 3, 1974, had all the characteristics in the southern hemisphere, just 30 miles wide. So they could be pretty large in their range, but it's the Saffir-Simpson scale that we use to rank them. Okay, let's talk about names. When it comes to the names we use for the Atlantic, and there are name lists for all the ocean basins, but let's talk about the Atlantic. What we do here is that we use names that reflect the languages spoke in the Caribbean, near the Gulf of Mexico, and then in the United States. So that's primarily Spanish, English, and French. We don't use certain letters, so no Q, U, X, Y, or Z. So sorry if your name is Quinn, Ursula, Xavier, Yolanda, Zoe. I just had to figure out some names here. You're never going to have a hurricane named after you. We only use a 21 name long name list. We alternate male and female names, and each year begins with either a male or a female. If we run out of names, like we did in 2005, the contingency plan used the Greek alphabet. So there's the list. And this list is repeating. So 2018, we start with Alberto. Finish, if it's a really active season, all the way down here with William. Now, as we go forward, you see 2019, 2020, 2021, 22, 2023. After this, 2024, we just reuse the 2018 list, unless we retire the name of a hurricane. Now, when you look at all the hurricane names, I'm going to be honest with you, my favorite one is Gaston. Okay, when I was a little boy, quite young, the Disney animated movie Beauty and the Beast came out. Remember this? Okay, Gaston. What a great name for a hurricane. But oftentimes these names are horribly mispronounced. Some of the worst ones, Umberto was a really bad one. Jose has been a hurricane, and people have really screwed that one up, which is amazing that they do that. Katrina has now been taken off. It's now been replaced by Katia. It's not Katia, it's Katia. And so there's a pronunciation guide that I'll link after this video that you can take a look at all of this. Now, what does it take to get a name off the list? We retire names that are particularly devastating, such that using the names would be very insensitive. What do I mean by this? Well, if you go down to New Orleans right now and you talk about Katrina, you will evoke some pretty powerful emotional response of that, because Katrina destroyed lives down there. We also retire hurricanes that we study a lot, which is generally the ones that are incredibly powerful and do a lot of damage. But that's how a name can come off the list. And when it comes off the list, we replace it with another name. Now, in a typical year, we make it all the way, this is normal, we would make it all the way to the L's. Okay, so if 2018 is normal, we'll go from Alberto, maybe the last one will be named Leslie. Okay, so if we get beyond that, that would be a much more active than normal season. So we'll have to wait and see how 2018 kind of shapes up here. All right, as we move forward, I'm going to show you the retired name list. So when you look at this, we only go back to 1954, and that's because before 1954, we didn't use names. There were several different naming conventions. One of the first was that we would just name the hurricane after the day it hit, like the Labor Day hurricane of 1935, or we'd name it after the location it hit, like the Great Miami Hurricane of 1926. We then used the phonetic alphabet, like Abel, Baker, Charlie, Foxtrot, that one, during our wars. But then in 1954, we came up with a name list. Really not we, the World Meteorological Organization did. And you'll notice that every name from 1954 to 1978 that's been retired here is a female name. We used to only name hurricanes after females until 1979, when the name list became both male and female. Now, when you look at it, we've had some particularly devastating years, like 2005 was a bad one, 2017 was a bad one, 1995 was a bad one, where we had a lot of these powerful hurricanes causing a lot of damage and destruction, and they retired. Some years didn't have any that retired, like 2006, 2014, 2009, just to name a few. But this is what the current retired Atlantic name list looks like through 2017. All right. Let me talk about why some hurricanes were retired as we finish up this video. That animation in the top there, we're watching Hurricane Joaquin. Joaquin hit the Bahamas and then turned right back around and went back out into the open Atlantic Ocean. But we had catastrophic flooding in South Carolina. And that was because on the northern side of Joaquin, wrapped into an upper level trough, a big stream of moisture hit South Carolina. And it produced a 1,000-year flooding event Over 20 inches of rain in just a few days. Joaquin, Category 4 in strength, 155 miles per hour, deadliest hurricane in the Atlantic since 1959. But what I mean by that was that it was the deadliest because it killed 34 people at sea. Did $200 million in damage, mostly here in the Bahamas, because we can't count the damages in South Carolina. But one of the most important things is it sunk the El Faro container ship. And I don't know why, but this container ship basically sailed right through the heart of Joaquin. So Joaquin, off the list. Let me show you another one, Matthew. Hurricane Matthew, a lot of people forget, but it absolutely destroyed parts of Haiti. And when it did so, well, we don't know what the final death toll was. It could be over 1,600 fatalities. But as Matthew went right along the coast of Florida, skirted along the coast of Georgia, and then hit South Carolina, ended up doing $15+ billion in damage. It was a Category 5 at its most intense right before it hit Haiti with 160-mile-an-hour winds. Because of the fatalities and because of the damage, Matthew is off the list. This is Harvey, the second most costly U.S. natural disaster as of June 2018. Look at that thing. Powerful, powerful hurricane hitting the Texas coastline. Look at this. That animation in the upper left tells you why Harvey was retired. You see, Hurricane Harvey did what we don't ever want a hurricane to do, and that is to stop and sit and spin over a location. This is what it's about to do over Houston. When it was all said and done, because the steering winds around Harvey slowed down and let it sit and spin, parts of Houston received over 50 inches of rain. I live in Champaign, Illinois. Annually, we get 40 inches of rain. And if you've never been here before, Champaign is absolutely flat. If we get 50 inches of rain, well, I'll just say it like this. We could rewrite Genesis chapter 7 here. There'd be no dry ground. When they went out to do search and rescue, see this picture up here? I got this picture from a guy that was in this particular flood. The search and rescue boats and the boat prop, the propeller, well, the water was so deep, it was hitting the tops of this van, which was submerged. See the scars across the top? And I met the guy that took this picture. This is a floating pile of fire ants. Yeah, the critters have to get out of the floodwaters too. What did we see in the end? 31 trillion, with a T, trillion gallons of water provided by the sky. Set a new U.S. tropical cyclone rainfall record of 51.88 inches. Harvey did it all with water. Incredible to see that. Let's talk about Irma. Irma was quite interesting. Irma was a powerful hurricane, major, Cat 3+, when it made landfall. It had been 12 years since a major hurricane hit Florida, though. And during that time, Florida's population grew by over 3 million people. That's the population of Chicago. Not Chicago metro area, but Chicago alone. When it went through, Hurricane Irma knocked out the power for over 6 million customers. Now that's just people that pay bills. It doesn't account for their families. Maybe as much as 10 million people or more did not have power. That's what the image shows you down there on the bottom. You can see the lights that were out because of Hurricane Irma. Now what I'll never forget was one of the companies I work for has some stores down in Central Florida. And they contacted me before Hurricane Irma made landfall and said, what should we do to help prepare our stores? And I told them, send every generator that you have on a truck down to Florida. You're going to sell out of them. They sold 20 truckloads of generators before the storm hit because in that 12-year time period, we had a lot of new vegetative growth and 3 million new people to Florida that had never experienced a powerful hurricane. And when the power went out, those people were buying generators. So neat to kind of see the economic impacts of this particular system. Now, one neat thing that happened with Irma was that when Irma was making landfall, it did so in a very interesting path, okay? So it came up across Cuba and then skirted across the Florida Keys and went in just like this. You see the counterclockwise circulation of the winds. Tampa Bay is right here underneath the cursor. And the winds were coming from the land basically to the ocean. We call this an offshore wind. And that actually pulled the water in the ocean away from Tampa Bay, which is incredibly amazing to see. But powerful, powerful Hurricane Irma. We'll talk more about storm surge and pulling water away from the ocean in this video lecture series. And to finish, I want to show you Maria. Maria, of course, has been retired. At its strongest, Category 5, 175 miles an hour in the wind speeds. Weakened as it hit Puerto Rico. $90 billion in damages. That's the third most costly on record. And at this point, we actually don't even know how many people were killed by it. There's a lot of controversy over this because when it hit Puerto Rico, I don't know how else to describe this, but the devastation was complete. The whole island at one point had lost power, and the food and water crisis has lasted for months. The infrastructure in Puerto Rico was already compromised, and when this hurricane hit, it just did it in because it was the second hurricane to hit Puerto Rico in 2017. So the name Maria is off the list. So, with this as our backdrop, as we learn about hurricane structure, hurricane formation, and the destructive powers of them, we need to keep in mind this background information so that we can fully understand how these tropical cyclones cause as much problems and do as much damage as they can.